Thank you very much. We have a wonderful event today, wonderful place, wonderful audience. Thank you very much for coming. So for my speech, I wanted to talk about a couple of projects we carried out with the Ministry of Agriculture in Turkey within a span of 5 years. If I can get one clicker to proceed with the slides. Okay, thank you very much. So this will be my agenda. First, there are two small topics. I would like to introduce myself a little better. And just to give the context for artificial intelligence, which is a very hot topic today, within the broad framework of computer science. So these two short topics, just an introduction. And then comes the bulk of my speech, which is about 4 projects. They have different aspects. The one of them is very high impact. Another one which is very easy for computer scientists to implement, but which is very valuable for the agricultural engineers, very useful. Another one, some challenging topic, and there is a high utility project. So I would like to try to fit these all in 30 minutes. Hopefully we will manage. Now, just a little bit info about me. I got my BS degree from Turkey, Middle East Technical University. My MS and PhD degrees from MIT in the United States. I have more than 3 years of industry experience working in different companies, mostly defense industry companies. Also, I did a military service, 1 year military service, and this was also technical work as well. Starting with my most recent academic experience, last month I joined Universum Collage as the head of computer science department in Kosovo. Before, I was in 3 years in Kazakhstan, Nazarbayev University, and before then 7 years in Middle East Technical University, Turkey. So these are brief experiences. My thesis work mostly on unmanned systems, unmanned ground systems, unmanned aircraft, some animations from what I did. And finally, the research, mostly me and my students, we applied artificial intelligence. It's applied intelligence. We started applying it to robotics, to map making, and more recently we started applying it to agricultural projects and also algorithmic trading. So how can we make more money by taking advantage of artificial intelligence, which is a very hot topic today. These are some posters, some pictures from projects we did. I especially wanted to emphasize the agricultural projects and also algorithmic trading projects more. Now, the second short topic is computer science. I know everyone here knows already the importance of computer science today. Everywhere we have microchips, and computer science is the branch of science, very hot topic today that deals with all these things. Not only, so you also see artificial intelligence as a sub-branch, but not only AI, there are other fields which enable us to build networks, which enable us to do computer graphics, entertainment, movies, everything basically. So we encourage our students to get a very solid, very good computer science education if they can, as much as they can. This will give them a head start in the industry. If we focus on AI, as I mentioned, it's a subfield. And as a definition, so AI is the sub-branch of computer science which aims to build software or hardware or together. So this might be a soft system, a hard tangible system, but the goal is to have a behavior that is similar to intelligent beings. Some examples here. IBM Watson, this system joined competition, Jeopardy competition, and beat his human opponents. You see chess playing systems beating humans. We have unmanned cars nowadays, and robots, and even Mars rovers, and financial systems. In the United States, more than 80% of all financial trading is done by robots right now, soft robots. So this is AI. What is inside AI? So in order to build smart systems, we need to borrow ideas from mathematics, statistics, we need language processing. If we are dealing with robots, we also need vision, we also need hardware. So we cooperate with mechanical engineers in order to build all these robots, etc. So this is just the context within AI. So I just wanted to set the stage. And this is my last slide about, okay. Now we start with our first project. All these four projects, they were carried out together with Ministry of Agriculture of Turkey. They provided basically data to us, I mean me and my students, and they also provided expertise in the domain expertise, and we did the research, we did implementation, delivery of products that I'm about to mention. Now, our first project was sunpest. Sunpest is an insect. It looks giant here, very scary, but it's actually the size of your fingernail. So this is a major enemy for wheat, one of the most important strategic products. So wheat is a strategic product during times of war or friction between countries. Usually countries stop selling each other wheat. This sunpest damages wheat fields to an enormous degree. So the major goal for this project is to determine the optimal time to apply pesticides in order to combat this insect. Now here is our solution, which I will explain later, some pictures. Now this is a more detailed story. Now, the life cycle of sunpest, it is in 3 phases. In the first phase, during winter and early spring, the sunpest actually stay in hills and mountains in an hibernation state. So this is phase 1. In phase 2, during springtime, close to summer, they travel from these wintering locations we call wintering headquarters to crop fields. This takes about 15 days, 20 days. And they fly individually, sometimes using their own wing powers and sometimes using wind mostly. So they travel from wintering sites to crop fields, and then they lay eggs. You see some eggs here. The eggs hatch. There are nymphs. Nymphs start growing in 5 stages. Stage 1, 2, 3, 4, 5, and then they become adults. And in the 3rd phase, these adults, after damaging the fields, they travel back to hills for the winter. So this is their life cycle. They have 3 stages. What we are interested in is stage number 2. So when they arrive at fields and when they lay eggs, then in stage 2, we keep an eye on the population of nymphs, these small offsprings. They also grow, and this is a regression problem. So when they grow to a certain stage 2, if the population of nymphs exceeds a threshold, this is the best time to apply pesticides. If you apply it earlier, it will not have any effect on the insects. If you apply it later, you already have all the fields damaged. So basically we want to know the phase 2 and the nymphal stage number 2 with a certain threshold. Now this is one part of the story. The other part is weather stations. Weather stations are collections of sensors. You can put them in your field. Farmers use it, meteorologists use it. So they are a collection of sensors. What kind of data they provide? They provide temperature, pressure, humidity, dew point, also temperature under the soil. Anyway, up to 20 different measurements can be received. And they also have internet connection and they store data in cloud. You can augment the data, let's say accumulated values, normalized values. So this adds up to 60 different readings per hour, but you can also collect them per day. Anyway, so for any given day, they can provide different readings. Now the weather stations can be put in the wintering locations and they can also be put in the fields. We had a mix of both actually. Now, so this is the setting for our project. The classical solution, the agricultural engineers, how do they usually do this pesticide application? They get on their cars when it's spring. They travel from field to field. This takes like 3 months duration. And then for every field, they do sampling. They count the insects. If they are above a threshold, they declare that now is the time for pesticide application. But this is error prone, it's also costly. In Turkey, in order to visit 150 fields, they spent 3 months, and also the cost is about 50 million Turkish liras, which is equivalent to 2.7 million euros. So this is the cost just to get these engineers traveling and doing measurements. Now, our solution, we trained 2 models. One model is predicting, actually we associated the life cycle with weather conditions because there is a cause-effect relationship between the two. Instead of focusing on the life cycle, we can focus on the weather conditions, just get data from the weather stations, and if certain conditions hold, we can say that, okay, the life cycle, now the phase is 2, 3, and the nymphal stage, etc. So based on these weather data, with 4 years of past prior data, we trained 2 models. We had 2 pilot fields, one in Aksaray, one in Kırşehir, 2 cities in Turkey. And our models actually did the classification for phase detection and then the nymphal stage population, so there's a regression. We built a web application. The web application daily fetches data, and then it has models for prediction. And if it is about to give warnings, the warnings can be given by SMS messages or subscription-based, so farmers can subscribe to this system to get information. So this became a live interactive system. Now the results I would like to share with you. Oh, actually these are model examples. What do these models look like? We have decision trees, and you see the important thing is there are different decision trees for different, specialized for different fields. Classically, agricultural engineers, they use a single formula for every field. But here, they are all specialized. And our regression models, you see how close they get to 0 error. So this was very successful. Now, this is the results of our first project. It was more than 99% accurate. At one time, actually, we built it over 4 years, and then we tested it for 1 year. The agricultural engineers physically went to the fields, they measured things, and they said, no, it's not the time yet. But our model predicted that now is the time. So they went back to the field, they checked it more carefully. By checking, it means counting the insects, looking under every leaf and rock, etc. So they decided the model is more accurate than their prediction. So they said, okay, the model is better than us. What else? The meteorology, the weather stations actually in Turkey, they are shared between the 2 ministries, Ministry of Weather, Agriculture and the Turkish State Meteorological Services. So the meteorological services, they ask the Ministry of Agriculture, wherever you want us, we can put these weather stations and you can use the data. We just need to know the data for our purposes, but the same stations can be used for your purposes as well. So this reduces the cost. The system collects data every year. This new data can be used to train the model further. So this is a self-improving system. And we did further optimizations. We did factor analysis. So we don't need actually these 60 different readings. We can only use 4 or 5 readings in order to get the same accuracy in our prediction. So this was also a further optimization. And finally, the sun pest and weed. So this pair of crop and insect, it's not limited to that. The same know-how can be used for other pairs like apple trees and their enemies, pests which affect apple trees. They also mentioned with their domain expertise that we can also use the same model to detect epidemic conditions as well. So this became a very successful application. In 2 fields, it was very successful. And they planned to apply this to other areas as well. At that time, I moved from Turkey to Kazakhstan, so I didn't follow up with them. But anyway, this was a very successful project. My second project is a follow-up. So in this map, you see at the center, we have the wintering locations, and there are circles you see drawn around. So this is a 10-kilometer radius circles. These sun pests, when they fly with wind, the maximum distance they can get is around 10 kilometers. So the second problem the ministry had was, let's try to find out which fields will be affected by these sun pests. Now, so this is basically the setting. certain other insects, they fly in groups and radars can be used to track where they landed. But here with sun pest, this is not possible because they fly individually. So these are our restrictions and the solution. So the biggest problem was agricultural engineers, they didn't know about geographical information systems. This is actually a pretty standard problem. So we applied a custom GIS solution. On top of it, we have the weather stations, we have the wind directions and wind speeds. We can accumulate them over time. So we added this knowledge as well on top of this system. Now the result is a heat map. So you see among all this area, the most likely places where the sun pests just landed are marked with this red. And this makes it very easy for the engineers to pinpoint where they need to go and check. This was also a very successful project. It didn't require any artificial intelligence, but anyway, it was also very successful. Now the third one is a different problem. In this problem, this is mostly with trees, apple trees and other kinds of trees. There is another way to measure the density of insects. It is sticky traps. Sticky traps are like papers with a certain color, usually yellow. You hang it on your tree, you wait for 1 week, and then the insects, they get stuck on this. And you need to count it. If the count is above a threshold, again, you need to take some action, like applying pesticides or maybe doing something else. Now, the problem is, the engineers, they used to count this manually. And sometimes there are hundreds of insects stuck on these papers, so they need to count it. Usually they assign this to interns, and some interns they were just making up numbers. They were not really counting things. They were just saying 800, 900, and then inconsistencies in numbers occurring later. Anyway, so that was a very tedious problem. Another thing is these traps are expensive, so sometimes farmers, they reused it. So for 1 week, they counted them. The next week, they used the same trap, and then they recounted and subtracted the past week's sums. Anyway, this was very difficult. So we had two goals here. We needed to count the insects within 95% accuracy. This was target one. The second one is classifying them, classifying these different types of subspecies of insects. Our results, the counting was very successful. We trained computer vision models with insect pictures, augmented with different rotations, different scalings. This was successful. The second part, actually, we failed there as well, because the difference between two species is so small that you need microscopic images sometimes to differentiate between the various species. So we were not able to be successful in the second goal. But the counting was okay. The farmers, they took pictures with their cell phones with high-dimensional pictures, and then they sent it to the server, and the server just counted them very well. And our last project, it's also in a different domain. Now, after harvesting, so there are these commodity markets, and these grains are also sold in commodity markets. Again, we focused on wheat, but the same know-how, same knowledge can be applied to other crops as well. Here I put some pictures just to give you the feeling of how it is in commodity markets. Traders, they come to these markets, they look at the products, and then they offer some prices to the producers, and this trading goes on. With stock markets, other types of financial markets, it's usually easier because the products, the stocks, options, these are fungible. Fungible means they are equivalent to each other. But no two bags of the same product, wheat, is equivalent. There are many things like the type of the wheat, the protein content, many other things. So all these bags, they are different. Now, the two problems is, so this product is not fungible. It is difficult to give a good valuation. The second is, in Turkey, there is an organization, governmental organization, Turkish Grain Board. They provide some guidelines to traders and also producers in how to value these, but these guidelines were mostly useless. So I will just proceed. Now you see, for wheat only, there are more than 40 different types of subspecies, so it is very difficult to value them. On top of it, you see these are the features that are found in the guidelines for this governmental organization. I will just give you some examples. For example, the protein content. And when you are harvesting, some grains might get damaged. So the ratio of damaged grains to the other grains. There might be other seeds. When you are harvesting them, you may collect other seeds together with wheat. So the ratio of this unwanted seeds inside your product. Anyway, you see there are many different features, and all these are inside the guideline book published by this organization. They say if the protein content is below this threshold, discount 5%, and then if the weight of a hectoliter is below this, you can find another 3%, etc. These guidelines are like a thick book, and they are useless. Practically, the traders, they don't use it. I will go back a little bit. How does the experienced trader do? They just scoop up one handful of these grains, they look at it, and then they immediately value it. They have a lot of experience, their valuation is the one that is used, but we don't know how to translate this experience into rules, into something that is practically useful. So this was our problem to work with. The guidelines not aligning with the trader practice. This actually undermines the organization of this, authority of this organization as well. Now the solution, our solution is, so we got data from the ministry. This was about wheat prices for 6 years, more than 7,000 transactions with the experienced traders. So we fit some models with this. This is model 3. Now the predictions from our model, they were actually pretty much aligned with the traders, experienced traders. So we can say that this project was also successful because we were able to capture this trader experience very well with our model. What else? The predictions are actionable. Even inexperienced traders, they can just use our system in order to get fair pricing information, which is as if an experienced trader did it. And it's also informative in a scientific way for producers as well, because we carried out a factor analysis with our results as well. So we now know, and we can tell the producers which factors are the most important in pricing. For example, it turns out the protein content has the highest influence in the price. So they need to be careful when they are growing things up. They need to keep an eye on this. The second one, weight per hectoliter. The third one. Anyway, so they know which factors affect the price the most, and they can actually pay attention to them. So this was also successful, useful, and actionable results we got from these projects. Now this is kind of a recap about what I wanted to share with you. If we have, I think we have more time. I can use this time, by the way, so thank you very much for attending, but we still have time. I will use this time to play a game. This is about, again, artificial intelligence. We are intelligent beings. We are making decisions, and we want artificial intelligence systems to also replace us, maybe in the future, or help us. But what is involved in decision making? So I just would like to, maybe we can play this game. So who wants to be rich? I will give you 2 options, and I will ask you to pick. At the same time, as developers, maybe you can think, if I was to build an artificial intelligence system to play this game for me, how would I program it? How would I create it to make this decision? Let's see if decision making is easy or not. So the first option is, you will take, I will give you 30,000 euros, you will pick it and go away without any strings attached. This is your first option. You will either pick this or the second one. Now, I haven't told you the second one yet, but is there anyone in the audience who would like to pick this first option without hearing the second option? Anyone? You say the second? Second is you get nothing, so you lose. Anyway, okay. So first option is this. You are all very cautious. You need to hear the second option. When I played this game, offered this game in Turkey, many people actually picked this first option without even hearing about the second. Anyway, second one is, we flip a coin. If it's heads, you get 100,000 euros. If it is tails, you get nothing. Now you see both options. By a show of hands, maybe, who would pick the first option here? We have at least one. Any other people? 2, 3, 4, 5. Okay, good. Now the others, probably they are good in probability theory, so they calculated the probability of, the utility here. So with 50% probability, you get 100,000 euros, which is equal to 50,000 euros. The first one is 30,000. Okay, good. Now I would like to change the game. Now the first option is get 30 euros and go away. The second is flip coin and either 100 euros or 0. Now, if you are to pick this, which one, the first one, anyone who changes the mind from first option to second or second to first. So there is difficulty in decision making. Now I will change the game. And actually this one is more interesting. So first option is get $30,000 euros. The second is flip a coin for 1 million euros. Can we see who picks the second option here? First option. There are more people who goes with the first option. But from the scientific point of view, the probability theory, it's the same with the original problem. So what makes this decision-making difficult? By the way, if you are choosing the second option, probably you are rich, your Ferrari is waiting outside, maybe. If we just recap maybe, so the thing here is, it's not only probability theory. So people developing artificial intelligence systems, decision-making systems, or systems that help people to do decisions, they not only use probability, they also make use of other branches of sciences, especially utility theory. Now, for people with less income, 30,000 euros is a lot of money. So they don't want to risk, even though the probability theory tells the second option is better than the first, but still they don't want to risk 30,000. But for rich people, if you are Bill Gates, if you are CEO of Amazon, so you wouldn't care about $30,000. You would just pick the second option to get a chance to win. Anyway, this is the scientific part. Just an interesting game to think about what is involved in building intelligent systems. Even as human beings, we have different things to consider when making decisions, and it actually takes a lot to create systems which will do the decision making for us, especially if it is important topics like in law, in healthcare. So these are really critical systems. They need to be developed by real professionals. And this is why maybe as someone coming from academia, we can express the importance of a formal education in computer science and artificial intelligence. So that's basically all I wanted to share. Thank you very much. If there are any questions, I would be very happy to answer. Okay, thank you very much again.